Hopefully you've now watched my video of the chain rule explained. So now we're just going to do all sorts of examples. So by the end of this lesson, you'll be able to find the derivative using the chain rule for all sorts of different functions. Okay, if you look at example 1, I have f of x equals 1 over the quantity 2x plus 5 raised to the third power. You might be thinking this would look like a quotient rule problem, but since 1 is a constant, I really could just start this by bringing the stuff in the denominator up top. So if I rewrite that, this will really just be 2x plus 5 raised to the negative third power. Now I'm pretty much ready to take my derivative. I do notice there are parentheses. We've got that wrapper going on. So I'm going to let the information inside be my unbelievably tasty chocolate. So we'll let that be our u. So I'm going to rewrite that. So that is actually u to the negative 3. So now when I take the derivative, we're going to bump the negative 3 out front. So I'll have negative 3 u to the, if I decrease my power by 1, I'll get u to the negative 4. And then don't forget that we can't forget about that chocolate. So we have to take the derivative of the 2x plus 5, which will be 2. Okay, now if I just multiply it out, negative 3 times 2 is negative 6, u to the negative 4. I'm now going to deal with that negative power by bringing it down below. So I'll get negative 6 over u to the 4. And then my last step is just to plug my u back in. So negative 6 over 2x plus 5 to the 4th. So that will be my derivative. All right, let's try another example. You'll notice in this one there are no parentheses, but actually I'm going to introduce them because a square root would be to the 1/2 power. So we're going to rewrite this as 3x squared minus x plus 1, that quantity raised to the 1/2 power. Now notice that I do have parentheses, so I've got my wrapper going on there. So now I'm going to let the stuff inside be my unbelievably tasty chocolate. So we'll let that be our u. So if I rewrote that, that's really u raised to the 1/2 power. All right, so now if we take my derivative, we'll bump the 1/2 out front, and then we still have u. If I subtract 1 from the power, I'll now get negative 1/2. And then don't forget the chocolate. We have to take the derivative of the u, and the derivative of that would be 6x minus 1. And I am going to go ahead and put that in parentheses because it was an entire quantity. All right, simplifying this a little bit, I notice that the u to the negative 1/2 needs to be moved down to the bottom. Notice up top I have a 1 and a 6x minus 1, which would just be 6x minus 1. And then over, the 2 is on the bottom, so it's going to stay on the bottom. And then u to the negative 1/2 would change to u to the positive 1/2. And I'm going to even go a step farther on that one. I'm going to have 6x minus 1 over 2. U to the 1/2 is actually the square root of u. And now my final step is to replace my u back into the problem. So my derivative is equal to 6x minus 1 over 2 square root 3x squared minus x plus 1. And there is my derivative. All right, example 3, kind of same thing as example number 1. Again, since there is a constant up top, we don't need to use the quotient rule, and I'm actually going to bring the denominator up. So if I rewrite that problem, it will be negative 4 times the quantity 5t plus 2 to the negative 2 power. And now from here, since we've got parentheses, I've got my wrapper, we can take our unbelievably tasty chocolate, call that u. And so let's rewrite it. So it's actually negative 4u to the negative 2. I'm now going to take the derivative of that. So bump my negative 2 out front. That will become a positive 8u. And then subtract 1 from my power. That will become a negative 3. And then I'm not done until I take the derivative. So let's not forget the chocolate. The derivative of u would be 5. And so now simplifying that, 8 times 5 would be 40, u to the negative 3. The next thing that I'm going to do, since we have a negative power, let's bring that back down to the bottom. And then to wrap that up, we just have to replace our u. So we've got 40 over the quantity 5 plus 2 raised to the third power. So that would be my derivative. Okay, number 4, we have f of x equals tangent to the 5th x, and you're probably thinking again, there are no parentheses, so how are we going to use the chain rule? Please keep in mind that when that 5 is in the place that it is, that really just means the tangent of x raised to the 5th power, and actually that's exactly how I would type it into my calculator. So on some of these, if you can think of where would I have to put parentheses to be able to type it in my calculator, that sometimes gets you unstuck. So once again, we've got parentheses, we've got our wrapper. So we're going to let the stuff inside be our chocolate. And then we're going to go ahead and rewrite that. So that's actually just u to the 5th. Now I'm ready to take the derivative. So the derivative is going to be 5u to the 4th And then don't forget, we have to multiply by the derivative of the u. And the derivative of the tangent is secant squared x. All right, really the only thing left I can do is just to plug my u back in. So I'll have 5, this will be tangent x to the 4th times secant squared x. And the proper way to rewrite this one would be 5 tangent to the 4th x secant squared x. And that would be my derivative. All right, number 5 we're going to save and do together. So let's go right to example 6. Okay, you'll notice once again on this example, y equals sine of 5x. There are no parentheses, but if you went to type this in your calculator, as soon as you put the sine function in, your calculator would automatically put a parenthesis there, and then we'd have 5x, and we've got another parenthesis. So now you'll notice we do actually have parentheses in our problem. So we'll let our parentheses be the wrapper. Our 5x will be our unbelievably tasty chocolate. And then from here, we can just rewrite that as the sine of u. Now I'm ready to take the derivative. So the derivative of sine of u will be cosine u. But we're not done until we've taken the derivative of our chocolate. So the derivative of 5x is 5. I'm going to rewrite that with the 5 coming first. So 5 cosine u. And then my last step is to actually plug the u back in. So I'll have 5 cosine 5x. So there we go. All right, my last example, y equals 2 cosine 3x. Again, if I were to rewrite this as I would if I were to type it in my calculator, I'd get a parenthesis right after I typed in cosine, and then 3x. Okay, so then from here we've got parentheses. So we will let the parentheses be the wrapper, and the 3x will be our chocolate. And so we'll make that u. So now if I were to rewrite this, I'll have 2 cosine u. I'm now ready to take the derivative. So the derivative of 2 cosine u is negative 2 sine u, and then don't forget we do have to multiply by the derivative of the u. So the derivative of the 3x is 3. Now simplifying this, negative 2 times 3 will give me negative 6 sine u, and then my last step is just to substitute the u back into my problem. So I'll get negative 6 sine of 3x, and that's the derivative. So hopefully now you can use the chain rule to find the derivatives of functions.